Welcome to Science Listener. Imagine standing on a silent world where the horizon stretches wider than you have ever seen. Above you hangs a pale orange sky, thin and fragile, with the faint disk of the sun glowing weaker than on Earth. The ground beneath your feet is red dust, ancient and cold, shaped by winds that have blown for billions of years. At first it feels still, almost timeless. Valleys carved by vanished rivers, mountains taller than anything on Earth, and a sky that holds 2 tiny moons racing quickly across the night. But then your mind stirs with a realization. This is Mars, a planet both close and unreachable, familiar in photographs yet alien in every breath. People have imagined it as a place of gods, canals, and lost civilizations. Today we know it as a frontier of science, where rovers wander in silence and orbiters trace invisible paths above. We see evidence of water locked in ice, signs of ancient floods, and a world waiting for human footsteps. In this journey, we will move step by step, from the raw landscape of Mars to the technologies that may one day let us live there. From the risks written in its thin air and radiation, to the dreams of turning dust and ice into oxygen, shelter, and fuel. Mars is more than just a red dot in the sky. It is Earth's neighbour, and perhaps humanity's next home, if we are bold enough to try. Close your eyes and imagine. A lone figure steps out of a habitat, boots pressing into red soil that no human has ever touched before. The horizon is quiet, the air unbreathable, yet above it all shines the same distant sun. And for a moment it feels as if the universe is holding its breath, waiting to see what happens next, and that is where our story begins. The silence after that first step does not fade. It stretches across the horizon, a thin echo that belongs to no earthly place. The dust beneath your boots is older than every city ever built, yet it feels fragile, as if it has been waiting for this moment. Air flows into your helmet through the regulator, too clean to be natural, metallic in taste, sharpened by filters and scrubbers. Every breath is borrowed time. The suit shifts against your body, joints releasing a faint sigh as pressure resists the void outside. Beneath your boots the ground crumbles like powdered glass. Martian dust clings to fabric, scratches visors, works its way into seals. Scientists warned of it long before the first step. Fine magnetic grains laced with perchlorates that disrupt thyroids and corrode steel. Lunar crews once cursed moon dust. Mars has taken that curse and added poison. Above, the sky holds a strange hue. Daylight scatters in iron-red haze, soft orange across the horizon, deepening to violet as the sun sets. The disk itself looks smaller, its light thin and tired, as though half a star remains after the long journey from 225 million kilometers away. Shadows fall hard, sharp-edged, stretched as if reality has lost some of its softness. Even sound feels weaker here. The atmosphere is less than 1% of Earth's, too thin to carry voices far. A shout would travel only a few meters before dying into silence. Phobos rises like a restless companion, racing from horizon to horizon in barely 4 hours. Its motion is so swift that you can track it with your eyes, a dark stone moving against the pale sky. Deimos follows at a slower pace, faint and timid, more like a star than a moon. Their rhythm feels alien, a reminder that time itself is measured differently here. On Earth, moons drift steady and slow. On Mars they seem nervous, hurried, out of balance. Behind you, the habitat glows softly, the only refuge on this endless plain. Thin composite walls buried under regolith for protection hold in every breath of oxygen and every drop of water. Inside, air loops through scrubbers, water cycles through filters, food grows in trays of nutrient solution. Power comes from solar panels spread across the dust, their surfaces vulnerable to storms that can cover half the planet. Small nuclear reactors stand ready as backup, heavy and costly yet essential. This place is not a home in the usual sense. It is a fragile bubble of technology, a lifeboat dropped onto an unforgiving sea. The ground remembers what has passed before. Viking 1 in 1976 returned the first images of rocks and sky, its camera capturing silence pixel by pixel. Sojourner in 1997 rolled across this same kind of soil, no larger than a microwave but carrying human curiosity further than before. Spirit and Opportunity in 2004 searched for traces of water, wandering far longer than their engineers had dared to hope. Curiosity in 2012 drilled into layered rock, uncovering minerals formed by ancient streams. Perseverance in 2021 carried Moxie, a machine that turned thin air into oxygen, proving survival was more than a dream. Each mission was cautious, mechanical, distant. The dust kept their tracks but never their warmth. Now there is breath, pulse, and heartbeat pressing against the suit. Mars draws us because it sits between myth and science. Once imagined as the home of gods and canals, then stripped to stone and sky by telescopes, now revealed as a planet that once had rivers, lakes, perhaps even seas. Water froze, atmosphere thinned, life, if it ever sparked, vanished or hid away. Still, it remains close enough to see with the naked eye, distant enough to demand courage. Humanity reaches for it not because it is easy, but because it resists. Every horizon here whispers that discovery is unfinished, that we're not yet done expanding the map. The silence of this world is heavy, yet full. It holds memory of machines, promise of colonies, and the fragile certainty that each step is both impossible and necessary. The sky darkens in a way Earth never taught you to expect. A deep orange fades to violet blue, the edges of the horizon glowing faintly as if the planet itself resists letting go of the day. The sun, already small and cold, slips behind the ridges, and the temperature begins to drop with a sharpness that feels alive. Within minutes, the warmth of the day vanishes, leaving air that bites at your suit, metal joints creaking with the change. Night on Mars is not simply darkness, it is a silence stretched to breaking, a weight that falls across the land. You stand in it and feel the press of cold through layers of insulation. The pumps in the suit hum harder, heaters strain, and still the sensation of exposure creeps into your bones. In the thin atmosphere, heat escapes too easily, like breath leaving a cracked vessel. Earth's night air holds you, Mars abandons you the moment the sun sets. Above the horizon, a dark stone rises. Phobos, misshapen and scarred, races across the sky like a restless shadow. You track it with your visor, a black lump moving steadily faster than any moon has the right to move. Barely 4 hours from rise to set, then it circles again, a pendulum no clock can measure. The sight unsettles the mind. Nights here are restless because the sky itself never sleeps. Farther away, Deimos appears. It shines faintly, smaller than the smallest star you can name, yet its motion is steady, slow, unhurried. The two moons create a rhythm no human grew up with, one rushing, one crawling. Together they pull at thought and imagination, reminding you that time here is not your own. The habitat behind you glows faintly under a thin shell of regolith. Its light is artificial, its warmth mechanical, its sound a vibration through the ground. Inside, crew gather to eat, measure supplies, check the systems that never rest. You know they mark every kilowatt hour, every gram of oxygen. A night storm could rise without warning. In 2018, such a storm covered the entire planet, choking sunlight for months and ending the mission of opportunity after 15 years. The crew checks their numbers because numbers mean life. Your helmet fogs for a moment as breath condenses on the visor. For a second, you feel the illusion of weather, like the mist of an Earth winter, yet here there is none. Mars has no clouds thick enough to carry rain, no air heavy enough to hold it. The most the planet offers are thin streaks of ice crystals or a rare whisper of fog clinging to valleys before dawn. The dryness is complete, absolute. Every drop of water you drink has been reclaimed, filtered, pushed through membranes until it tastes of nothing. Time stretches during the night. Each sol lasts 24 hours and 39 minutes, almost Earth-like, yet the difference becomes real in the long pause before morning. Your body expects dawn sooner than it comes. Sleep is uneasy under alien moons. Heartbeats feel too fast in the stillness, as though your body itself is impatient. Through the silence you hear only the suit, the soft hiss of oxygen, a faint buzz of heaters, the steady thump of your pulse. No insects, no leaves, no distant dogs or passing cars. Nothing but your presence in a world that does not care you exist. The realization is not frightening. It is clarifying. You're here because humanity refuses to stop at one world. You're here because silence invites answers. The night sky spreads wider than any cathedral. Stars blaze without haze, sharper than at Earth's highest mountains. The Milky Way is a silver river, clear and piercing, its light untrembled by atmosphere. Against it, the two moons cross like errant sparks, reminders that Mars has its own companions. Every constellation looks familiar, yet alien under this thin air. For centuries, people on Earth looked up and pointed at Mars, a bright red wanderer. Now the roles reverse. Standing here, you look back and Earth is the faint star, home reduced to a dot. The horizon stays still, the dust unmoved, the cold deep. Silence of the alien sky presses close, yet in that silence lies the first truth of living here. Survival means accepting emptiness as a companion. The glow of the habitat draws your eyes back from the stars, a faint beacon wrapped in dust, small against the immensity of the plain. Its walls look solid from outside, a pale dome half buried beneath regolith. But up close the truth is clear. Layers of polymer, aluminum, and insulation are thin enough to puncture with a careless strike of a tool. Pressure inside is 15 pounds per square inch. Pressure outside barely a whisper. Every wall is a frontier, holding death at bay with millimeters of engineering. You cycle through the airlock and the difference is immediate. The sound of pumps replaces the empty silence. The taste of scrubbed air replaces the metallic dryness of the suit. Inside, the air is not fresh. It smells of plastic, disinfectant, human breath. Food and sweat linger faintly, recycled through filters but never erased. The odour is not unpleasant, but it is constant, a reminder that this world offers nothing for free. The habitat vibrates faintly as systems work. Fans push oxygen through ducts, water pumps thrum in the walls, heaters click and hum to fight the cold. Power readouts glow on every panel, kilowatt hours are counted like coins. Solar arrays outside generate most of it, but the crew knows storms can smother them in dust. A compact reactor hums in reserve, heavy and expensive, but the only insurance against the planet's indifference. You pass the galley. Trays of hydroponic greens grow under LED lamps. their leaves a brilliant unnatural green against the beige of the habitat. Each plant is tracked, logged, weighed. Every drop of water that feeds them has passed through countless cycles: sweat, breath, condensation, filtration. The coffee in your hand may have been water vapour in a crewmate's lungs last week. The recycling system is precise, relentless, and it must be. Mars gives no rivers, no rain, no mercy. Crew gather at the table. They eat carefully measured portions, rehydrated meals, small servings of lettuce or microgreens from the trays. No feast, no indulgence. Hunger is never sharp, but appetite is always present. Stories are told quietly, voices soft, laughter subdued. The sound is human, but tinged with caution, as though loud joy might shake the walls. Radiation shielding is the invisible guardian. Outside, cosmic rays and solar storms batter the planet with little resistance. Earth's magnetic field is absent here, the atmosphere too thin to block much. Inside the habitat, meters track exposure. Regolith piled over the dome adds some safety, yet no one forgets that doses accumulate. 600 millisieverts in a year is common on the surface, a level that would trigger alarms for any Earth-based worker. Every soul adds a number to a growing total. The math of survival is constant. You move to the sleeping quarters. Narrow bunks line the walls, each curtained for privacy. A faint hum of fans mixes with the soft snores of those already asleep. Dreams here are strange, shaped by fatigue, isolation, and the knowledge of distance. Outside, Earth shines only as a dot in the sky, 14 minutes away by radio signal. Messages come delayed, conversations stagger into half-silences. Loneliness grows in the gap between questions and answers. The habitat is fragile, yet it is alive. It hums, it breathes, it holds warmth against the void. Every screw, every seal, every circuit is part of the body that sustains the colony. Without it, Mars offers nothing but silence, cold, and dust. With it, life exists where it should not. Stories about Mars began long before the first spacecraft ever touched its surface. Human imagination filled the red point in the sky with gods, cities, canals, and signals from neighbours who never answered. Ancient astronomers tracked its strange path, a wanderer that reversed direction against the backdrop of steady stars. To them it was not just a planet but a sign of war, a red omen tied to battles and blood. The colour alone was enough to spark fear and awe. In the 19th century, telescopes brought the planet closer. The Italian astronomer Giovanni Schiaparelli described canali on Mars in 1877, channels that soon became mistranslated as canals. The word was enough to unleash a storm of fantasy. Writers, scientists, and dreamers began to picture an ancient Martian civilization, desperate for water, building enormous canals to save a dying world. Percival Lowell spent years sketching these imagined networks, turning blurred telescope images into maps of alien engineering. No clear evidence ever confirmed the canals, yet the idea lingered. Mars was not just a planet. It was a mirror of Earth's future, a warning that civilizations could fall to drought and dust. By the early 20th century, fiction filled in the gaps. H.G. Wells gave the world The War of the Worlds in 1898, casting Martians as invaders with technology far beyond ours. The Red Planet became a stage for stories of conquest, survival, and apocalypse. Radios carried Orson Welles' broadcast in 1938, terrifying listeners who believed invasion was real. Mars was already a part of popular culture, a place both feared and desired, an alien frontier people thought might one day meet us halfway. Then came science. In 1965, the Mariner 4 probe flew past Mars, sending back the first close images. The pictures were shocking. No canals, no cities, no oceans, just craters and deserts. The romantic planet of canals and civilizations collapsed overnight, replaced by a barren world more like the Moon than Earth. The disappointment was deep, almost personal. People wanted neighbours. Instead, they found silence. Yet silence can be powerful. It does not erase curiosity. Viking 1 landed in 1976, proving that Mars was not unreachable. Its cameras showed rocks, dust, a horizon under a salmon-coloured sky. The images were empty, yet they felt intimate, like postcards from a relative who had finally arrived at a distant home. Life, if it ever existed, was nowhere to be seen. Still, the fascination remained. Each mission since has revealed more layers, evidence of ancient riverbeds, minerals formed in water, polar ice that grows and shrinks with the seasons. Mars went from imagined civilization to silent desert, and then to something even more compelling, a planet that once had water, warmth, perhaps even life. That tension is what holds us. Mars is both dead and alive in memory, dead in the silence of its rocks, alive in the signs of what it once was. The idea that a world so close to Earth might have followed a path toward habitability but lost it awakens something in us. It makes us wonder whether Earth is fragile in the same way, whether time will strip away our rivers and skies as it stripped Mars. You stand under the thin air, knowing that myths and science now meet in your presence. The gods of war have given way to machines that measure isotopes, drill cores, and sniff the air for methane. The canals of fantasy have been replaced by data on subsurface ice and permafrost. What fascinates is no longer the hope of intelligent neighbours, but the possibility of finding fossils of microbes preserved in stone, waiting through billions of years. Mars captivates because it resists. The journey here takes 6 to 9 months. The surface batters you with radiation, chokes you with dust, starves you with cold. Yet the red sky still pulls us forward. It is close enough to be possible, harsh enough to test everything we know. Humanity thrives on frontiers, and this is the last visible one before the stars. The planet is not a paradise, not even a garden. It is a desert wrapped in poison air. Still it holds meaning, because in its silence we hear ourselves. Every myth, every telescope sketch, every mission has been part of a single story. The desire to belong somewhere larger than Earth. That is why the fragile habitat behind you matters, why each bolt and seal is a declaration. Mars is not just a place to survive, it is a story we have told ourselves for centuries, now written in dust beneath your boots. The horizon does not stay calm for long. From a distance it looks like a haze, faint at first, then thickening, a moving wall that creeps across the plain with a patience more dangerous than speed. Dust on Mars does not rise like on Earth, stirred by winds and settled with rain. Here there is no rain, no weight of water to push particles back down. Grains are light, finer than talcum, electric with static charge. Once lifted, they can stay suspended for weeks, drifting until they become a shroud over an entire world. You notice the change in light before you feel the wind. The sun dims, the shadows fade, and the land loses its contrast. What was once sharp becomes flat, as if someone has turned the brightness down on reality itself. The visor darkens automatically, but even through the filter you see the glow turn weaker. Mars receives less than half the sunlight Earth does, and during storms even that half can vanish. Solar panels outside the habitat lose efficiency minute by minute, their surfaces coated in dust so fine it almost behaves like smoke. Wind rattles against your suit, a dry hiss. It does not carry the roar you would expect because the air is too thin to make a soundstorm. Yet the movement is relentless, and the pressure pushes on you in a way that feels eerie, like being touched by something insubstantial. The suit sensors pick up vibrations, the force real enough to tilt small machines and bury equipment left in the open. What begins as dust becomes dunes overnight. In 2018, a global storm rose from a local squall. It spread until it covered the entire planet for months. From orbit, Mars looked like a uniform beige ball, every landmark erased. Opportunity, the rover that had lasted since 2004, went silent as sunlight disappeared. Engineers listened for months hoping, until NASA declared the mission over in 2019. The storm was not violent in the way Earth storms are. No thunder, no floods. Its violence was in patience, in the quiet suffocation of light. Inside the habitat, alarms ring when dust density climbs. Solar output graphs fall like a heartbeat slowing down. Batteries drain, rationing begins. Kilowatt hours are measured with the precision of a surgeon's cut. Heaters dim, lights switch to red to conserve power. Hydroponic trays cut cycles to save energy. Crew huddle in dim corridors, listening to the muted hiss of dust against walls, counting hours until skies clear. Stepping outside in a storm is madness, yet sometimes it becomes necessary. Panels must be cleared, equipment retrieved, antennas adjusted. You step into a world without distance, where horizon and sky blur into a single moving brown fog. Visibility shrinks to meters, then less. The dust clings to joints, crawls into seals, grinds against every moving part. Static builds until sparks jump between surfaces. Helmets fog with fine coating, and inside you breathe louder because the world outside has disappeared. The strangest part is the light. Even at noon, the storm turns the land into twilight. The sun becomes a faint disk, pale and uncertain, like a coin seen through dirty glass. Shadows vanish entirely, leaving no depth. Walking feels like floating in a void painted the colour of rust. Your brain fights it, craving edges, searching for contrast. Disorientation sets in, not from noise or chaos, but from monotony. Everything is the same, a sea of dust shifting without end. Dust storms do not just swallow the sun, they change time itself. Days blur together when every hour looks identical. Crew lose track of schedule, waking and sleeping under constant dimness. Isolation deepens. Conversations fall quiet, energy conserved even in speech. The storm presses not only against walls but against the mind. Scientists on Earth measure such storms with orbiters like Mars Reconnaissance Orbiter and MAVEN, tracing how dust heats the upper atmosphere, lifting itself higher than physics on Earth would allow. Some particles reach 50 kilometers up, where thin air scatters sunlight into strange glows. Infrared sensors see the planet's heat balance shift. What begins as a ground wind becomes a climate event, written into the thin air for months. You look at the panels half buried outside, their surfaces coated in red powder, and you realize survival here depends on cleaning, storing, waiting. Storms cannot be fought, only endured. Generators hum in the background, a reminder that technology is the only shield. Without it, the storm would reduce everything to dust, hide every trace of effort, and leave the land exactly as it was before you arrived. The horizon is gone now, dust has swallowed it, the sun has dimmed to a ghost, and the world holds its breath until light returns. The storm eventually clears, but the threat never truly leaves. Beyond dust and cold lies another enemy, one you cannot see or hear, radiation that seeps through the sky itself. On Earth, a magnetic field and thick atmosphere shield you, bending solar particles aside and absorbing cosmic rays before they reach the ground. Mars lost its magnetic field billions of years ago. What remains is an open sky, a thin film of air, and every human who sets foot here becomes an exposed experiment. You check the dosimeter on your wrist, the numbers rising slowly but without pause. On Earth, a dental X-ray is over in a flash, a few microsieverts gone as soon as it starts. Here, the exposure never stops. Every soul adds more. Measurements from Curiosity in 2012 showed that a trip from Earth to Mars could expose astronauts to about 0.66 sieverts, nearly a career limit for some agencies. On the surface, it continues at roughly 0.64 millisieverts per day. The numbers look small until you live them. Over months they climb like a tide, invisible but heavy. The danger is not immediate pain. Radiation here is patient, rewriting cells in silence. DNA strands snap, repair mechanisms falter, mutations seed themselves like unwanted guests. The risks are cancer, damage to the heart and brain, cataracts clouding the eyes. Some effects may take decades, others strike sooner. Studies on Earth, from Hiroshima survivors to Chernobyl workers, gave grim lessons. Yet those events were sudden blasts. Mars offers no blast, only a steady drizzle that never ends. You feel nothing while standing on the plane, yet the body knows in ways the mind cannot. Eyes tire faster under the constant glare of ultraviolet. Skin itches at times, though meters insist the dose is within tolerance. Sleep grows restless, dreams fractured. Some astronauts on long missions report vision changes. Fluid shifts inside the skull, pressing against the eyes. In orbit around Earth, this syndrome already appears. No one knows what years on Mars will do under a sky that blocks almost nothing. The habitat protects, but only to a point. Regolith piled thick over the dome shields part of the spectrum, turning walls into crude armour. Water tanks lined sleeping quarters, doubling as both storage and radiation buffer. Engineers design bunkers beneath the surface, safe zones where crew can hide during solar flares. A violent coronal mass ejection could send a wave of charged particles that reach Mars in less than a day, stripping electronics and human cells alike. Forecasting helps, but prediction is imperfect. The sun is moody, and here you are far from Earth's shelter. In 1972, a massive solar storm struck space between Apollo missions. If astronauts had been caught outside Earth's magnetosphere, the dose could have been fatal. That fact lingers in every calculation for Mars. The journey itself, 6 to 9 months through deep space, is as dangerous as the destination. Once on the surface, radiation does not vanish, it simply changes form, cosmic rays becoming the endless background music of life here. You walk through the habitat corridors at night, passing meters glowing faintly, each one a reminder. Numbers creep upward even while you sleep. Shielding helps, routines help, but there is no escape. Outside the thin dome, the universe sends its message constantly. Survival here is possible only because of vigilance. The strangest part is how silent it feels. Dust storms roar in their way, power systems hum, footsteps echo. Radiation offers nothing, no colour, no sound, no taste. Yet it is always present, a second atmosphere invisible and unforgiving. Every step on Mars carries another danger, not from the sky above but from the ground beneath. Dust that clings, scratches and poisons without mercy. The surface looks solid from a distance, a patchwork of rocks and plains, but beneath your boots it behaves like powder. Grains are sharp-edged, ground fine by billions of years without rain to smooth them. They wedge into seams, grind against fabric, cut into plastic. What looks like harmless soil is closer to broken glass mixed with rust. You take a step and hear the faint crunch, almost too soft for the ear, carried poorly in thin air. Yet inside the suit the sound travels through contact, a vibration in your bones. Dust lifts with each motion, clinging to the boots, coating the joints in red. Once inside the habitat, it rides with you. No matter how careful, some grains find their way past airlocks, into filters, onto skin. Crews joke that Mars is a roommate who refuses to leave, but the humour hides real fear. Martian dust is more than a nuisance. Instruments on Phoenix in 2008 confirmed what earlier missions suspected. Perchlorates, reactive salts, make up roughly 0.5% to 1% of the soil in some regions. On Earth, such chemicals are used in fireworks and rocket propellant. Inside the body, they disrupt thyroid function, weaken metabolism, and poison tissues. The fine grains can lodge in lungs, carrying perchlorates deep into bronchi. Inhalation without filters would mean slow damage, not immediate suffocation, but a creeping illness written into every breath. Apollo astronauts once spoke of lunar hay fever, coughing and sneezing after exposure to moon dust. That dust lacked perchlorates. Mars adds another layer of danger. Filters must work constantly. Airlocks must scrub every suit with brushes, vacuums, chemical baths. Without strict discipline, the habitat could become contaminated, turning safety into another trap. The dust is alive with static charge. As storms sweep across plains, grains collide, building electricity until sparks leap between surfaces. Electronics short, sensors misfire, comms break. Even inside, static creeps through panels. Engineers warn that a single discharge in the wrong circuit could cripple a habitat. To live here is to manage not only what you see, but what clings invisibly to every surface. You imagine touching a visor scratched by dust. The clarity fades, vision blurred by fine etches that grow with time. Each outing costs glass, metal, fabric. Nothing lasts long against the slow grind of this soil. Boots wear faster, seals need constant replacement. Mars erodes technology the way it eroded its own rivers, slowly, relentlessly, with no concern for what it destroys. The smell inside the habitat after a storm is faint but noticeable. Filters capture most of it, yet something metallic lingers in the air, a reminder of where you walked. Clothes hold a dry, acrid scent, not dirt in the earthly sense, but a sterile harshness that irritates the nose. Food tastes flat after breathing that air too long, the tongue dulled by the metallic trace. Outside, dunes form quickly. What looks like a flat plain one day becomes a ridge the next. Small machines left unprotected vanish under drifts. Panels buried in red powder stop producing energy. Rovers from past missions have been swallowed by the land they studied. Wheels frozen in place, cameras blind. Mars does not forgive stillness. Anything left unattended becomes part of the ground again. The toxicity is not only chemical but psychological. Knowing that every step scatters poison wears at patience. Jokes fade when cleaning routines consume hours, when every breath inside feels slightly tainted. Dust is the constant reminder that this world is not yours. It enters lungs, scratches visors, dulls solar panels, and coats every dream in rust. Every system inside the habitat works like a heartbeat, steady only as long as nothing interrupts it. Survival here is not strength, but balance. A missed calculation, a failed seal, a storm arriving an hour too early. Any of these can tip the scale. On Earth, a mistake can mean inconvenience. On Mars, it means the end. Inside the habitat, the air feels thick with machinery. Fans spin constantly. Filters hum. Pumps circulate water through tubes. Their noise blends into the background until silence becomes more frightening than sound. If a pump stops, if a gauge falls quiet, hearts quicken. Every crew member knows the system is fragile, stitched together by engineering, time, and vigilance. Power is counted in kilowatt hours, rationed as carefully as food. Solar panels outside gather light, yet dust storms can steal the sky for weeks. In 2018, an entire planet turned beige under a storm that ended the rover opportunity. Engineers on Earth listened for a reply for months, but silence became the answer. That memory sits in every crew member's mind. A machine with 15 years of service ended not by failure of design, but by a sky that refused to give light. Radiation adds its own steady weight. Meters climb slowly, like sand filling an hourglass. Regolith over the habitat walls reduces exposure, water tanks help, but the numbers never fall. A coronal mass ejection from the sun could arrive in less than a day. Earth's magnetosphere once bent such storms aside. Mars offers no such shield. Hiding underground, shutting down systems to prevent overload, waiting. This becomes the plan. Survival is patience, not resistance. Food is measured by grams. A tray of lettuce leaves under LED lights becomes not just a meal, but proof of endurance. Every drop of water comes from sweat, breath, condensation. Recycled endlessly, it loses taste, becomes neutral, almost metallic. Drinking it feels more like refueling than refreshment. Hunger does not arrive as sharp pain, but as a quiet awareness that nothing is abundant. Sleep is shallow. The hum of systems never stops. The air never smells fresh. Dreams fracture under the awareness of distance. Earth is 14 minutes away by radio, years away by return flight. Conversations with home are half dialogues, questions waiting long minutes for answers. In those pauses, the crew feels the fragility most. The planet does not speak back. Outside, the ground is silent but hostile. Dust creeps into seals, scratches visors, poisons airlocks. Radiation pours from above, invisible and relentless. Temperatures swing from thin daylight warmth to deep cold at night, dropping below -70. The horizon stretches wide, but it offers no comfort. There are no forests, no rivers, no birds, only silence, dust, and a fragile bubble of life fighting to hold its shape. Survival here means living inside numbers. Pressure, 101 kilopascals inside, 600 pascals outside. Oxygen, 21% in the dome, less than 1% in the thin air. Temperature, steady within the walls, deadly beyond them. Each number must stay within limits. Each system must work. Every day is an equation that must balance. The fragility does not weaken the story, it sharpens it. Each sunrise, each breath, each meal is earned. Life here is not routine, it is defiance. Mars remains indifferent, yet the presence of a fragile habitat is already proof of something larger. Humanity's will to hold on even where it should not survive. At the edges of certain craters, the red soil breaks away to reveal something unexpected. Sheer walls of ice, shining pale blue beneath the dust. These scarps look like frozen cliffs on Earth, layered sheets of water locked away for millions of years. In 2018, orbiters mapped them in detail, showing ice only a meter or two beneath the surface, stretching downward for tens of meters. It was not theory, but proof. Mars still holds enormous reserves of water, hidden in plain sight. The cliffs gleam in the thin sunlight, brighter than surrounding terrain. Dust cannot hide them entirely. Each layer is a record, ancient snowfalls compacted over ages when the planet's tilt shifted and polar ice crept toward mid-latitudes. Mars has no oceans now, yet here lies the ghost of seas, preserved as buried ice. From orbit, instruments like Sharad on the Mars Reconnaissance Orbiter confirmed what the eye already suspected. These cliffs are vast, not patches, but deposits comparable in volume to Great Lakes on Earth. You approach one in your mind, the suit crunching over frozen soil. The visor reflects a wall streaked in white and blue, cracked with fractures, shining faintly against the red dust. Cold radiates outward, a chill you can almost feel through the suit. Scraping at the wall releases powder, dry and crystalline, melting instantly inside the warm glove. The taste in your imagination is sharp, clean, pure. Water that has not flowed in billions of years. The discovery of near-surface ice changed colonization plans. No longer was water something to be hauled from Earth at impossible expense. Instead, it could be mined, melted, purified. Tanks inside the habitat could be filled from the ground itself. Electrolysis could split the liquid into oxygen to breathe and hydrogen for fuel. Mars was no longer only dust and poison. It was also a reservoir, waiting for human hands. In 2008, the Phoenix lander confirmed ice at its landing site near the pole. Its robotic arm scraped soil and uncovered bright patches that sublimated within days. Later missions refined the picture, showing how ice lies across vast plains, sometimes just beneath the surface. For future colonists, these locations become maps of survival. Build near the cliffs, and water is only meters away. The cliffs are not gentle sources, they erode. Dust covers, ice sublimates, layers fracture. Yet even with loss, the quantity is staggering. Some deposits hold volumes equal to Earth's Great Lakes. Imagine the promise. Entire colonies sustained, greenhouses watered, fuel factories supplied. What once seemed like fantasy becomes logistics. You stand before such a wall in thought, listening to the faint creak as temperature shifts crack its surface. The sound is tiny, almost lost in the thin air, yet it carries through the ground into your boots. The cliff is not dead. It moves slowly, releasing grains and shards that scatter into the dust. Each fragment is a reminder that beneath the harshness lies abundance. Water on Mars is not rivers or rain. It is hidden, locked away, waiting beneath soil and cliffs. Finding it has turned a barren planet into a place where survival is not only possible but sustainable. Across the plains lie scars of another time, wide basins rimmed with deltas and channels, the bones of lakes that once filled and vanished too quickly. The names are familiar to science now: Jezero, Gadl, Eberswald. Each crater tells the same story written in stone. Water once stood here, pooling, rippling, carrying sediment, then leaving forever. Jezero became famous in 2021 when Perseverance touched down. The rover rolled across an ancient delta, its cameras tracing fan-shaped deposits left by rivers that no longer flow. Clay minerals there formed in water, clays that could have sheltered microbes from radiation. Scientists believe the lake existed billions of years ago, perhaps 3.5 to 4 billion. That number is almost too large to grasp, yet standing on the surface you feel its absence directly. The cracked floor, the layered edges, the silence where waves never return. Gale Crater tells the same tale. Curiosity has wandered its slopes since 2012, drilling into rocks that smell faintly of sulphur when powdered, a sign of minerals born in liquid water. Mount Sharp rises from its centre, a stack of layers taller than the Grand Canyon's walls. Each layer records a climate, wet at the base, drier above until the water was gone. Curiosity's instruments tasted complex organics in those ancient rocks. Not proof of life, but proof that the ingredients once existed. The lakes dried too fast. Mars lost its thick atmosphere early, its magnetic field fading, and the sun stripping air into space. Without pressure, water boiled or froze, vanishing from the surface. What remains are shorelines fossilized in dust, channels cut deep but never filled again. You can walk along them now, boots crunching on sediment that once lay underwater. The air is so dry it pulls moisture from your lips, a constant reminder that these basins are graves, not fountains. You imagine the sound of waves against the crater rim, then compare it to the silence now. The brain craves the rhythm of water, but only dust answers. The smell is of iron, dry and metallic. Taste comes only from recycled water in your suit, flat and lifeless compared to the ghost of rivers that once carved these stones. Orbital images reveal networks of valleys feeding into craters. From above they look like branches of trees, dendritic patterns carved by liquid flow. On Earth, such shapes appear only when rivers persist over long time scales. On Mars they mean water was once stable on the surface, not fleeting frost but real streams under a thicker sky. Instruments on Murrow and Maven have traced minerals like clays, sulfates, carbonates, all signs of water's hand. Yet no drop has touched this ground in billions of years. In 1971, Mariner 9 became the first spacecraft to orbit another planet. It looked down on dust storms that swallowed half the world, then cleared to reveal river channels stretching for thousands of kilometers. Scientists saw canyons, deltas, dry lake beds. The dream of canals was gone, but a new truth arrived. Mars had been wet. The evidence was carved into its bones. The tragedy is scale. Lakes here did not vanish over centuries, but in planetary heartbeats. Climate shifted, atmosphere escaped, and basins like Jezero became empty before life had much chance to rise. For colonists, the lakes remain valuable not for water, which is gone, but for sediments that might hide fossils of microbes. Perseverance collects cores there now, caching them for a mission that may one day bring them back to Earth. Inside those rocks may lie the first direct evidence that life is not unique to one planet. Walking across such a crater feels like walking through time. Each step lands on sediment that once sank in a lake bed. Each ridge marks an ancient shoreline. The silence is heavy, but your imagination fills it with ripples, currents, the faint slap of waves on rock. Then the taste of dryness returns, lips crack, and the truth settles again. The water is gone, leaving only evidence. Mars captivates not just because it holds ice today, but because it once held oceans, rivers and lakes, and lost them. To see the scars is to see fragility, the possibility that Earth too can change, that climate and air are not permanent gifts. These dry basins warn as much as they inspire. Beneath the dust lies another promise, not in vanished lakes but in frozen reservoirs waiting for drills and heat to set them free. Ice does not gleam here like the cliffs at crater edges. It hides under soil, preserved by cold and pressure, sometimes only a metre or two beneath your boots. In other places it lies deeper, tens of meters down, layered in bands that once shifted with the tilt of the planet. To reach it means digging, scraping, melting, turning red desert into a source of breath, food, and fuel. You picture the sound of a drill biting into regolith. It screeches faintly through the suit, a vibration that climbs up your arms. Dust clouds rise first, iron red and fine, clinging to gloves, coating every joint. Then a pale glimmer appears, ice crystals reflecting weak sunlight. They do not melt under the open air. On Mars, ice sublimates directly, vanishing into vapour. Only inside sealed chambers warmed carefully can it be captured as liquid. The process feels less like mining and more like surgery, precise, patient, every gram accounted for. Colonists treat water like treasure. Tanks line habitat walls, not just for storage but for radiation shielding. Pipes hum as pumps push reclaimed liquid through filters. Showers become mist sprayers lasting seconds. Laundry means wiping fabric with damp cloths. Even so, consumption is measured down to decimals. To dig reservoirs is not luxury but survival. 1 ton of ice means thousands of litres of air, meals for months, fuel for rockets waiting in silence. In 2008, Phoenix scraped into soil near the pole and revealed bright patches of ice that sublimated in days. In 2016, orbiters mapped thick deposits in Utopia Planitia, volumes equal to Earth's Great Lakes. Those images changed mission planning. A colony near such reservoirs could sustain itself indefinitely. For engineers, the challenge became simple to state and hard to solve. How to harvest ice without wasting it to the thin air. Concepts multiply. Heated probes that melt down like spears, gathering liquid before it evaporates. Augers that drill, lift and funnel ice into sealed containers. Microwave devices that warm soil gently, releasing vapor into collectors. Each has flaws. Too much heat, and water vanishes before it is trapped. Too little, and drilling breaks machines faster than it yields results. On Earth, failure means delay. On Mars, it means thirst. You bend near a fresh borehole in thought. The smell inside the habitat after melting ice is almost non-existent. Neutral, clean. Yet the taste on the tongue is different, sharper, like air caught in liquid. Colonists notice. They call it the taste of Mars, water untouched since ancient floods, stored away until hands reached it again. Drinking it feels ceremonial, a connection to billions of years. Reservoirs underground are not uniform. Some regions hold nearly pure ice, others mixtures of dust and frozen brine. Briny water is harder to use, requiring more purification, but it offers lessons. Salts preserve, salts alter chemistry, salts once flowed in channels. Every sample drilled carries history as well as survival. The scale is humbling. Orbital radar suggests that subsurface ice across Mars could equal the volume of the Arctic Ocean. Not all of it is reachable, but enough lies close to sustain outposts and eventually cities. A single deposit in Utopia Planitia could support thousands of people for generations. Colonies will not grow in deserts far from water. They will root themselves where ice lies closest, like ancient villages on Earth, building beside rivers. You wipe frost from a glove in imagination, seeing it evaporate instantly into thin air. The silence swallows the act, yet the meaning is enormous. Each gram trapped is air to breathe, fuel to burn, food to grow. Mining ice is not mining in the traditional sense. It is the art of pulling life out of a frozen grave. What ice truly means is not just liquid to drink, but the foundation of everything a colony needs. Breath in the lungs, fire in engines, and food on the table. Every litre pulled from the ground multiplies itself into forms of survival. Melt it and filter it, and you have water to drink. Split it with electricity, and you have oxygen to breathe and hydrogen to fuel rockets. Run it through plants, and you have leaves and grains to eat. Ice is the quiet alchemy that turns a dead planet into a place where life can stretch its roots. Inside the habitat, the tanks hum as pumps push melted ice through filters. The sound is steady, a reassurance. You take a sip and the taste is faint, metallic, neutral. Yet in that flatness lies comfort. This water was soil a day ago, frost an hour ago, vapour seconds ago. Machines turned it back into liquid, and now it cools your throat. The body accepts it with gratitude, even without flavour. Oxygen comes next. Electrolyzers bubble faintly, splitting water into gases. The hiss of O2 filling tanks is more precious than any melody. Without it, lungs would fail in minutes. Colonists measure oxygen not only in litres but in hours of life. Charts line the control room, production rates, reserves, daily needs. Numbers carry the weight of breath. Hydrogen, light and restless, is stored for fuel. Combined with carbon dioxide from the thin air, it feeds reactors that synthesize methane. Rockets built to return home or leap onward to other destinations depend on this process. The concept was proven in 2021 when Perseverance carried Moxie, showing that Martian air could yield oxygen. Scaling it with water ice closes the loop. Mars becomes not just a destination but a refueling station for the wider solar system. Plants thrive only with water. Hydroponic trays glow under lamps, roots floating in nutrient mix. Each drop is rationed, yet each leaf is a victory. Colonists describe the smell of damp roots as the only real scent of Earth inside the dome. Salads grown in such trays taste sharper, fresher, not because the chemistry is different, but because they are rare. Water runs beneath every bite, invisible yet essential. History on Earth shows the same truth. Civilizations grew where rivers flowed, Nile, Tigris, Indus. Where water was abundant, cities rose. Where it failed, kingdoms fell. Mars repeats the lesson with brutal clarity. Build near ice, and you have a colony. Build without it, and you have a grave. You watch condensation gather on the inside of a visor after a long walk outside, droplets catching the light before being wiped away. That small shimmer carries the same meaning as entire reservoirs. Water is survival, in breath, in flame, in food. Mars does not give it easily, yet it gives enough. The path forward depends on turning every gram of ice into more than it is. Drink, breathe, burn, grow. Each function interlocks with the next, a cycle of survival wrapped around frozen stores beneath your feet. Above the ground where ice hides, the sky itself offers little mercy. An atmosphere made almost entirely of carbon dioxide, thin enough to suffocate in seconds. The pressure at the surface averages less than 1% of Earth's, about 600 pascals. Imagine standing on the summit of Mount Everest without oxygen, then stripping away 2/3 more. That is what greets you here. You step outside the habitat and the body knows instantly. Without the hiss of suit pumps feeding oxygen, lungs would collapse, blood would boil, consciousness would vanish in less than a minute. The thin air cannot push against skin, cannot hold heat, cannot carry sound. Breathing it is impossible not because it lacks oxygen alone, but because there is almost no air to draw. The composition is cruel. 95% carbon dioxide, less than 3% nitrogen, traces of argon, oxygen less than a fraction. No comfort, no softness, only a choking mix. On Earth, carbon dioxide is measured in hundreds of parts per million, and already we worry about its rise. Here it is almost everything. Every exhale would be no different from the sky itself. Frost forms at the poles each winter as carbon dioxide freezes into dry ice, locking away nearly a third of the atmosphere. In spring it sublimates again, rushing back into the sky, swelling pressure slightly. The entire world breathes this cycle, a seasonal inhalation and exhalation written in frost. Colonists mark the change carefully, watching gauges tick higher, then lower, knowing that air here is unstable even as poison. Sound travels strangely. Words drop into silence after only a few meters. Shouts fade as if swallowed by dust. Engineers recorded this in 2021 with perseverance. Microphones picked up faint whistles of wind, a bird-like warble from the rover's laser as it struck rock. Higher frequencies vanish quickly, lower ones crawl through the thin air. For crew, the effect is eerie. Helmets carry voices electronically, but outside the world itself offers almost no echo. The taste of recycled oxygen inside the dome is sharp, metallic. It carries hints of plastic from pipes, dryness from filters, yet compared to the outside sky, it is paradise. Imagine opening the visor even for a second. The lungs would burn, chest convulsing against vacuum. There is no mercy in the atmosphere of Mars. Dust storms add their own tricks. Carbon dioxide is already thin, but storms lift particles so fine they thicken the air to vision while offering no help to breathing. The sky turns beige, the sun shrinks to a disk, yet pressure hardly changes. It feels heavier only to the eyes, not the lungs. History told this truth early. In 1976, Viking landers measured the atmosphere directly, confirming it as mostly carbon dioxide, thin and dry. Later missions refined numbers, but the lesson never changed. Mars has a sky, yet it might as well be none at all. You stand beneath it and realise survival here means never meeting the planet on its own terms. Breathing must always be through machines, through domes, through tanks. Mars offers ground to walk and horizons to watch, but it will never offer air to share. Yet in 2021, a small golden box the size of a toaster hummed inside Perseverance, proving that even in this hostile air, oxygen could be pulled out of carbon dioxide. The machine was called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, a long title reduced to a word that sounded almost friendly. It was not large, not powerful, but it carried the weight of centuries of imagination. The idea that Mars itself could help humans breathe. MOXIE worked by drawing in thin Martian air, compressing it, and running it through a solid oxide electrolyzer. Carbon dioxide split into oxygen and carbon monoxide. The oxygen streamed out pure, measured by sensors before being vented back into the sky. Each run produced only grams per hour, enough for a small dog to breathe. Yet the meaning was vast. For the first time in history, a human machine had taken alien air and turned it into something lungs could use. The sound of MOXIE was soft, fans whirring, pumps pushing, a faint buzz of electricity. Nothing dramatic, no flames or roaring engines, just quiet persistence. You imagine standing nearby, hearing the hum echo faintly through the rover's shell, knowing that each second the machine was making air where there was none. Over the course of its mission, MOXIE produced 122 grams of oxygen. That is roughly what a single human breathes in 10 minutes. By itself it was almost nothing. In meaning it was everything. The principle was proven. Mars does not only take, it can give. You picture breathing that oxygen. The taste is the same as on Earth, clean, sharp, invisible. Yet you would know it was different. Born from carbon dioxide molecules that floated in a sky no human could ever inhale directly. To drink in that air would feel like victory, however small. Engineers talk in scales. A scaled-up version of Moxie could produce kilograms per hour, tons per year. Colonies would need it not only for lungs but for rockets. A single Starship leaving Mars would require hundreds of tons of oxygen. Carrying that from Earth is impossible. Making it on Mars is the only path. Moxie was the first stone in that road. The principle reaches deeper. Imagine rows of machines working day and night, humming as they split carbon dioxide endlessly, feeding tanks, filling habitats, charging fuel cells. Imagine a colony breathing because a fleet of golden boxes refused to stop. Mars would remain hostile, but machines would tip the balance. History on Earth is full of such beginnings. The first steam engine was small, inefficient, more curiosity than revolution, yet it lit the path to industry. The first radio crackles carried only faint sounds, but they opened voices to continents. Moxie is the same, a quiet device that whispers of futures larger than itself. You step outside in thought, visor fogging faintly with your breath. This sky remains poison, but somewhere inside a rover, oxygen is being made molecule by molecule. The knowledge changes how you see the horizon. Mars is not only survival through storage and recycling, it is survival through transformation. The idea has haunted scientists and dreamers alike. If machines can make oxygen, perhaps one day the entire sky could be remade, turning a dead atmosphere into something humans could breathe. This vision is called terraforming, reshaping a planet to fit human needs. For Mars, it means building an atmosphere thick enough for lungs, warm enough for rivers, stable enough for life. You imagine stepping outside without a suit, air cool but breathable, sky tinted blue rather than orange, frost melting into streams that carve across valleys. The mind wants to believe it. The body aches for it after months of recycled oxygen and metallic water. A horizon where you could simply inhale feels like paradise. Ideas for how to achieve it fill libraries. Some suggest releasing greenhouse gases, trapping heat until polar ice sublimates, thickening the atmosphere. Others propose giant mirrors in orbit to warm the surface, or nuclear devices to shock carbon dioxide loose from the poles. Each plan sounds bold, cinematic, almost desperate. The problem is scale. In 2018, a study using data from EMRO and MAVEN concluded that even if every molecule of carbon dioxide locked in the soil and polar caps were released, the pressure would rise only to about 7% of Earth's. Still too thin to breathe, too cold to keep water liquid. The dream falters under math. Mars simply does not hold enough air to give. History whispers warnings. On Earth, climate can shift in decades. Ice ages advancing, deserts spreading, oceans rising. Mars experienced its shift billions of years ago when its magnetic field collapsed, stripping atmosphere into space. Reversing that process would require technology humanity does not yet have, energy on planetary scales, resources beyond what a single world can provide. Terraforming remains an idea that inspires novels more than engineering. In the 1990s, writers like Kim Stanley Robinson painted vivid pictures of Mars being warmed, flooded, seeded with plants. His trilogy began with Red Mars in 1992, capturing imaginations. Yet even fans of the dream admit the timescale is centuries or millennia. Colonists alive today will not see it. Their children will not see it. The project would demand persistence far beyond human political cycles. Still, the vision matters. It is a beacon, a reminder that Mars is not just a tomb of rivers, but a canvas for imagination. Colonists may never walk without suits, yet imagining it pushes research. Machines like Moxie prove small steps. Greenhouses prove the possibility of controlled habitats. Ideas of mirrors, gases, and microbes keep minds restless. You close your eyes and picture the sound of wind through trees transplanted to this world. The thought itself becomes nourishment in a place where lungs know only filtered air. Reality is harsher. Pumps hum, filters buzz, air remains poison. Yet the dream endures because humans are restless creatures. Mars resists, but minds keep asking, what if? Inside the habitat, survival reduces itself to numbers on screens, each one linked to the simple act of drawing a breath. Pressure, 101 kilopascals inside, 600 outside. Oxygen, 21% in the dome, less than a fraction beyond the walls. Carbon dioxide scrubbers running at 99% efficiency. Every gauge is a measure of lungs, every chart a record of life continuing. You notice the hum of the air system most at night. Fans never stop, pushing currents through ducts, mixing, filtering, balancing. The sound becomes background until it changes. A sudden silence is worse than any alarm, a reminder that breath itself depends on machines. Astronauts on the International Space Station learned this long ago, but Mars makes it heavier. There is no fast return, no quick rescue. If a scrubber fails, the air inside thickens with carbon dioxide. Headaches arrive first, then dizziness, then the slow drift of unconsciousness. On Earth, you could open a window. Here, there are no windows. Carbon dioxide removal is constant labour. Lithium hydroxide canisters absorb it, but they fill quickly. Regenerative systems heat sorbents, vent waste back outside, recycle filters for reuse. Colonists joke that Mars is one big CO2 canister, waiting to smother them if they stop paying attention. Yet the joke carries truth. Meters glow softly, ticking levels up and down, the line between safe and dangerous never more than a few digits apart. Breathing is science in rhythm. Electrolyzers split water, feeding oxygen tanks. Monitors track every molecule added, every leak accounted for. In 1971, during the Apollo 14 mission, engineers worried over a single oxygen tank's pressure reading. Here, that concern is magnified daily. Oxygen is not only for lungs, but for fire in stoves, oxidizer in engines, fuel cells humming quietly in storage rooms. Each breath competes with other needs, and priorities are balanced carefully. The taste of air is subtle. Recycled oxygen feels dry on the tongue, metallic in the throat. Colonists describe it as sterile, a little sharp, carrying the memory of pipes and filters. After weeks it becomes normal, but the body remembers forests, oceans, rain. Dreams bring back the smell of wet earth after storms, and waking means returning to air that is mathematically clean but sensually empty. You inhale and hear nothing unusual, yet the mind plays tricks. The awareness that without pumps and gauges the next breath would never come sharpens every inhale. Breathing becomes conscious. Some crew count the seconds of their own respiration at night, reassuring themselves that machines still hum. Others learn to ignore it, to treat air as background again. Everyone finds their own balance. Emergencies are rehearsed constantly. A sudden leak in the dome, a puncture from micrometeoroids, a seal failing in the lock. Pressure drops in seconds and alarms scream. Crew practice sealing hatches, patching breaches with resin that hardens in thin air. They time themselves not in minutes, but in breaths. Training repeats until it becomes muscle memory. You know in your bones that 3 deep inhalations might be all that separates you from collapse. The numbers stretch into the future. Long missions measure exposure, not just suffocation. Oxygen excess fuels rust in metal, brittleness in plastics. Carbon dioxide buildup shifts moods, blurs concentration. Studies on submarines and Antarctic stations warn that air quality changes the mind as much as the body. Mars will test that truth harder than any earthly environment. The fragility is never forgotten. Machines hiss, tanks refill, scrubbers glow with warning lights. Outside, the air is poison. Inside, it is an equation solved every second. Every inhale is a small triumph of engineering. Every exhale a promise that systems still hold. Survival here is not dramatic. It is measured in the science of every single breath. The next question is where to live, because thin domes and fragile walls are not enough. Protection must come from the planet itself, from the dust and rock that once seemed only hostile. Mars forces settlers to think not of glass domes sparkling under the sky, but of shelters buried beneath the regolith, hidden from view, yet safe against the things the surface cannot forgive. You walk across the plain and imagine the weight above. A metre of soil can cut radiation nearly in half. 3 meters can bring it down to level survivable for years. Engineers know the numbers, and they translate them into shovels, bulldozers, and robotic diggers. The regolith that scratches visors becomes a shield when piled thick. What once was an enemy turns into armour. The process begins with machines. Rovers scrape and scoop, blades pushing dust into berms around inflatable habitats. Layers of regolith are poured, compacted, pressed, until the structures vanish under mounds of red. From a distance, the colony looks less like a settlement and more like a series of low hills. Life hides beneath them. The sun may rise and storms may rage, but the settlers remain wrapped in their own small underground world. Inside such shelters, the air is cooler, the sound muted. Radiation meters tick lower. You taste recycled oxygen with the same metallic tang, yet the knowledge that layers of soil block cosmic rays adds comfort. It is not silence alone that protects, but mass. Even the weight of dust despised outside becomes welcome. In 1972, a solar storm erupted with a force that would have been fatal to astronauts beyond Earth's shield. Historians of spaceflight repeat the lesson often. Without cover, cosmic events are killers. Mars offers no magnetosphere, so colonists create their own shield by digging. Safety is not found in height, but in depth. The act of burial changes psychology. To live beneath soil is to abandon windows, to accept that horizons will not be seen each morning. Screens replace skies, projections replace sunsets. Some crew miss the open view, others find the underground calm soothing. A reminder that danger stays outside. Walls thick with regolith muffle the thin hiss of wind. For the first time since landing, settlers sleep without counting every particle of radiation. Dust does not only bury habitats from above, it becomes part of construction itself. Pressed into bricks, mixed with binders, it forms walls stronger than fabric alone. Each scoop of regolith serves double duty, a shield and a building block. Colonists joke that Mars is not a planet but a quarry. Its first gift, the material of its own defense. The body feels the difference. Outside, skin prickles with cold, ears strain in silence, lungs depend on filters. Inside a buried shelter, the air is still artificial, but the sense of safety is stronger. Sleep deepens, muscles relax, headaches fade. The ground above gives weight, but also relief. You understand why ancient humans on Earth built caves into hillsides, why armies dug trenches, why miners lived near shafts. Protection comes not from what you build upward, but from what you hide beneath. Mars teaches the same truth with sharper edges. To survive here, you do not stand tall against the sky. You let the dust cover you, and in that surrender find strength. If dust can bury a shelter for protection, it can also be shaped into the walls themselves, printed layer by layer until a house grows out of the soil. The dream of 3D printing on Mars is no longer fantasy sketches in magazines, but a field of experiments on Earth and prototypes in labs. The planet offers no forests, no quarries of timber, no convenient steel mills. What it does offer is endless regolith, sharp, fine, toxic, but abundant beyond measure. Turning that into structure is the challenge that architects and engineers now embrace. Imagine the sound of a giant nozzle spraying slurry made from Martian soil. Pumps hiss, robotic arms swing, vibrations thrum through the ground. The dust, once just a hazard, becomes paste, melted with binders, fused by microwave beams or sintered with focused sunlight. Each layer hardens, another ring on a growing cylinder. Within hours, the outline of a habitat rises where before there was only sand. Experiments on Earth show how it might work. NASA's 3D printed habitat challenge in 2019 produced domes, arches, and test modules from simulants of Martian soil. Teams used basalt-based powders, sulfur binding, even bacteria to solidify regolith. Some models withstood pressure equal to what domes would face under Martian atmosphere. What once looked like science fiction now has prototypes sturdy enough to shelter lives. You picture standing inside such a printed room. The walls are thick, rough to the touch, carrying the gritty smell of heated dust. The air inside still hums with machines, but the sense of permanence is stronger. Unlike inflatable domes, these walls do not rustle or shift. They stand silent, heavy, absorbing sound. The body relaxes against them, convinced by mass that safety has grown. Printing from soil offers more than walls. Vaults, arches, tunnels, designs impossible with flat panels, become possible when material is laid grain by grain. Colonies could sprout structures like termite mounds, each tailored to hold radiation back and heat in. These shapes need not copy Earth houses. They may follow physics of dust and gravity instead. In 2019, engineers tested microwave sintering of regolith simulant, producing bricks that fuse solid without cement. In 2020, ESA experiments showed sulfur-based construction, heating regolith until sulfur melted and bound grains into concrete-like blocks. On Mars, sulfur is abundant, a byproduct of volcanic history. The planet itself provides the chemistry to make homes. You run a gloved hand along a wall in thought. It feels rough, uneven, almost alive. Heat radiates faintly from where microwaves fused layers. Dust still clings in corners, but the form is solid. A home pulled not from imported steel, but from the very ground that tried to kill you. Survival becomes symbiosis, using the enemy as material for refuge. There is poetry in it. Humans arrive on a planet with nothing but machines, and the first true houses rise from dirt. Each brick is local, each curve a response to radiation, storms, cold. Over time, a colony printed from soil might look less like an outpost and more like a village of sculpted stone. Mars would shape architecture as much as architects shape Mars. Long before printers and bulldozers, the planet carved its own shelters, vast lava tubes that lie hidden under the surface, waiting in silence like natural cathedrals. These tunnels formed billions of years ago when molten rock flowed across the young world. As outer layers cooled into crust, rivers of lava drained away beneath, leaving hollow caverns behind. On Earth, such formations exist in Hawaii and Iceland, but on Mars they are larger, wider, and more stable thanks to lower gravity. Scientists studying images from orbit, especially from Ro's high-resolution camera, spotted collapsed skylights, holes in the ground that reveal darkness beneath. Some may open into caverns hundreds of meters across, stretching for kilometers. If confirmed, these would dwarf any lava tubes known on Earth. For colonists, such voids are not just geological curiosities, they are potential homes. You imagine descending into one. The air is thin and still, temperature steady near -20, insulated from the extremes above. Boots crunch on rock that once glowed molten, now cold and brittle. The sound echoes strangely, bouncing from walls unseen in the dark. Light from your helmet spreads only a few meters before being swallowed, reminding you how vast the space is. Silence presses close, heavier than outside, as though the ground itself is holding its breath. The appeal is obvious. A lava tube offers natural shielding from radiation, protection from micrometeoroids, and insulation from daily swings of temperature. Where the surface plunges from daylight chill to night frost, the cavern remains steady. Colonists could set habitats inside covered not by artificial layers of regolith but by stone thick enough to laugh at cosmic rays. Exploration has only begun. In 2007, Mars Odyssey spotted hints of caves near Asia Mons, one of the Great Shield volcanoes. In 2020, studies using MRO data suggested tubes up to 1,000 times larger than Earth's. If true, entire cities could fit underground, domes and towers built in caverns without ever seeing storms or dust. You picture standing in such a cathedral of stone, the ceiling arches far overhead, rough, irregular, but grander than any human hall. Your footsteps echo, delayed, repeating until they blur into a low hum. The air smells of nothing, dry and lifeless, but the space feels alive because of scale. Colonists described the motion as awe, a reminder that Mars, even while hostile, offers beauty. Building inside tubes would not be simple. Dust covers entrances, stability must be measured, supports added, lighting must be constant or darkness swallows everything. Yet the advantages outweigh the labour. Radiation drops to levels safer than surface shelters. Storms above become irrelevant. Colonies inside could expand without hauling regolith endlessly. The idea is not just survival, but culture. Imagine a community gathering in a cavern lit by soft lamps, voices echoing against basalt walls, children running through tunnels, their laughter mixing with the hum of life support systems. Farms under artificial sun lamps filling part of the cavern, green against black stone. The comparison to cathedrals is not exaggeration. These voids inspire reverence, not only utility. You touch the wall in thought, cold and rough, a reminder of volcanic fire long gone. The rock is both barrier and promise, ancient danger transformed into shelter. Mars created these halls before humans existed. Now they wait, silent, until breath and light return to fill them again. Shelters that last only a season may keep explorers alive, but colonies demand more. Structures designed not for weeks of survival, but for generations of life. Inflatable domes patched and buried may serve the first crews, yet no one dreams of raising children in them. To imagine permanence on Mars is to think in centuries, not missions. Engineers sketch plans for habitats that merge with the planet. Walls thick as medieval fortresses, built from regolith bricks fused by heat. Vaulted ceilings printed with geometry that spread stress evenly, resisting collapse. Floors embedded with pipes for water circulation and heat exchange, keeping interiors steady. Each detail must last through storms, radiation, and time. You picture walking through such a settlement. The air still hums with machines, but walls no longer tremble at every gust outside. The ground does not shift under pressure of dust. You smell recycled oxygen mixed with faint traces of stone warmed by hidden pipes. The sound is muted, soft, not from fragility but from mass. The place feels permanent. On Earth, permanence is assumed. Houses stand for decades, cities for centuries. On Mars, nothing is assumed. Metals fatigue faster in radiation, plastics embrittle under ultraviolet, seals age in dry cold. A structure that lasts 10 years on Earth might fail in 2 here. Designing for generations means planning for materials that heal themselves, for maintenance robots crawling through walls, for systems built to renew rather than decay. History shows the contrast. Antarctic bases were built for expeditions, then reinforced for permanence when scientists realized they would stay year after year. The same transition will occur here. Outposts become towns, towns become cities. One date marks the shift, 2030s, when NASA sketches human missions not as brief landings but as long stays. Those plans already imagine modules expandable into villages. Mars forces the same evolution of thought, from survival tents to architecture. Colonies that last must also consider culture. Rooms cannot be only labs and bunks. Children will need schools. Families will need privacy. Communities will need halls for gathering. A settlement is not only engineering but emotion. Without beauty, life in tunnels will feel like prison. With beauty, light, open halls, even gardens under glass, it becomes home. You sit in thought on a bench imagined inside such a hall. Around you glow panels that mimic skylight, shifting from dawn to dusk. Plants rustle in a controlled breeze, the only sound close to Earth's. The body relaxes not just because the air is safe, but because the place feels human. That is the science of longevity, designing not for explorers but for generations unborn. Energy begins with the sun, yet on Mars its light arrives weaker, filtered through dust and distance, leaving solar panels both lifeline and liability. The planet receives less than half the solar power Earth does, about 43%, simply because of its greater orbit. At noon, the sun looks smaller, its rays stretched thin across the red sky. Panels that could power homes on Earth produce barely enough here to keep heaters humming. You stand beside a field of arrays planted in the dust. They tilt toward the faint disk, motors whining as they track the slow arc. Dust coats the surface almost immediately, reducing efficiency with every hour. Colonists scrub them with brushes, send robots crawling over the glass, even shake them with vibrations to dislodge particles. Yet storms always win. The panels never shine for long. The sound of boots on the grit mixes with the creak of structures. In thin air the noise feels muted, but inside the helmet every vibration carries. You wipe a gloved hand across one panel, leaving a streak of clarity, light glinting brighter through the visor. The act feels satisfying, yet it must be repeated endlessly. Mars is a world where housekeeping becomes survival. History proved both hope and danger. In 2004, Spirit and Opportunity landed with panels as their only source. They lived far longer than designed, helped by Martian winds that occasionally swept them clean. Spirit lasted until 2010, trapped in soft soil, while Opportunity endured until 2018, when a global dust storm ended its voice. Engineers still remember the silence, a reminder that reliance on the sun here is fragile. Modern colonies plan redundancy. Arrays stretch across hectares, tilted at angles to catch the low arc of winter light. Some designs bury half the panel to protect it from storms. Others cover them with transparent shields, hoping to reduce dust. Power storage is always paired. Batteries lining habitat walls, fuel cells ready to carry the load when storms dim the world. Still, every colonist knows the sun is not steady here. You feel the cold creep even while panels glisten faintly in afternoon light. Heaters draw kilowatts every hour, air pumps run without pause, greenhouses demand steady cycles for crops. The math never stops. Each watt-hour is tracked, rationed, and defended against dust. To step outside at night and look over the colony is to see faint glows, not bright city lights. Mars forces humility, every lumen earned. Solar power is fragile, yet it is also constant in one way. The sun always returns. Storms clear, panels are brushed, batteries recharge. The rhythm is slower, harsher, but it exists. Colonies cling to that rhythm, counting on each dawn to bring just enough energy to hold life in balance beneath the dust. When storms darken the sky for weeks, survival turns to another source, a core of steady heat hidden in metal, the nuclear heart of the colony. Solar panels fail, batteries drain, but a small reactor hums without pause, feeding kilowatts day and night. It is not sunlight, but fission that steadies life under the dust. You stand in the power room, boots on steel flooring that vibrates faintly with energy. The sound is low, a steady hum, almost soothing. Air feels warmer here, not from heaters but from the core itself, heat bleeding through pipes into every corner of the habitat. The smell is metallic, sharp, mixed with a faint tang of coolant. Colonists half-jokingly call this room the hearth, the fire that never dies. Nuclear systems on Mars begin small. The Kilopower project tested units on Earth in 2018, showing how a reactor the size of a barrel could produce up to 10 kilowatts. Enough for lights, pumps, and heaters in a small outpost. On Mars, such units can be buried under soil for shielding, linked in clusters for redundancy. Unlike panels, they do not care if dust storms cover the sky. Their fuel lasts years before replacement. You imagine pressing a gloved hand to a wall above the reactor pit. It vibrates gently, a pulse like a heartbeat. Outside, storms may rage, the sun may fade, but inside this hum continues. The psychology matters as much as the power. Knowing that light and heat will not vanish with the weather steadies nerves. Colonists sleep deeper when the reactor runs. The history of reactors in space reaches back decades. In 1965, the Soviet Union launched satellites powered by fission. In 1973, NASA used a small reactor aboard Apollo's ALSEP experiments left on the Moon. Later missions favoured radioisotope thermoelectric generators, smaller but weaker. Mars demands more than trickles of energy. It demands a fire strong enough to run farms, labs and factories. Critics worry about risk. Launching uranium through Earth's atmosphere stirs fear of accidents. Engineers counter with design, cores sealed, tested to survive explosions, buried on arrival. Colonists cannot afford hesitation. Without steady power, greenhouses fail, heaters shut, oxygen plants stall. Nuclear energy is not luxury here. It is pulse. You step back into a corridor, hearing the hum fade behind bulkheads. The air feels cooler instantly, thinner in comfort. Yet you know that without that reactor, even this breath would not exist. Solar panels may glow each dawn, but only the nuclear heart guarantees that the colony beats through endless winter. Even with sunlight and reactors, survival depends on storage, the quiet batteries and cells that hold power through the hours when generation falters. The Martian night is long, nearly 12 hours, and each one must be bridged by reserves. Panels sleep under stars, reactors hum steadily, Yet without banks of stored energy, the colony would lurch between abundance and blackout. You walk past a wall of batteries. They are not small, not the kind you slot into flashlights, but cabinets the size of coffins lined in rows. Cables snake across the floor, fans whisper, a faint chemical tang of lithium fills the air. The temperature here stays carefully controlled. Too much heat and the packs risk runaway fire, too much cold and efficiency drops. Crew members call this room the stomach of the colony. It digests energy, saves it, and feeds it back when demand peaks. Numbers matter. A habitat of a dozen people might consume tens of kilowatt hours each soul. Heaters, scrubbers, lamps, comms, drills. Batteries must cover spikes, storms, mistakes. Engineers talk in cycles, in depth of discharge, in capacity fading over time. On Earth, a dead pack means inconvenience. On Mars, it means the silence of stopped pumps. Fuel cells add another layer. Tanks of hydrogen and oxygen feed stacks that hum softly, producing electricity and water as byproduct. The sound is low, almost a purr. Colonists describe it as reassuring, the opposite of the eerie stillness outside. Each watt from a cell feels like a promise, especially when storms stretch longer than predicted. History offered lessons. In 1997, the Sojourner rover lasted far longer than its primary mission, thanks to careful use of solar power and batteries. In 2012, Curiosity ran on a radioisotope generator, but still carried batteries to manage peaks. Perseverance in 2021 followed the same pattern. Human settlements magnify those lessons. Storage is no longer accessory but backbone. You imagine standing in the habitat when lights flicker. A warning tone rises low and insistent. Power draw exceeds reserves. The hum of pumps shifts as systems cut back, heaters dim, greenhouses flicker red. The smell of warmed electronics grows stronger. Crew check screens, ration immediately. Fear arrives not as panic but as mathematics. Every % loss tightens the chest. At night, the colony glows faintly against the dark. Each light is powered by layers of storage. Batteries beneath floors, cells humming in racks, generators feeding the grid. Outside, the land is silent, frozen, indifferent. Inside, energy flows in loops, measured and guarded. Survival is not only generation, but the discipline to save, store, and release in rhythm. You touch the cool casing of a battery pack in thought, the metal vibrating faintly with current. It feels alive, a reservoir of invisible strength. Without it, the night would swallow every breath. Winter on Mars is not only cold, it is a season that tests every system, stretching power, food, and patience to the breaking point. The planet tilts on its axis much like Earth, giving it seasons, yet with thinner air and greater distance from the sun, the effect is brutal. Polar caps of carbon dioxide expand, pressure drops, and temperatures dive below -80. For colonists, winter is not scenery. It is survival measured in watts and calories. Inside the habitat, heaters roar softly day and night. The air smells dry, tinged with plastic warmed by constant current. Fans hum, pumps circulate fluid through pipes in the floor, every machine working harder. Power draw spikes and reserves shrink. Solar panels yield little under the low sun, often half buried in frost and dust. Arrays tilt desperately toward the horizon, scraping what light they can. Nuclear units shoulder the burden, reactors humming steadily beneath soil, their vibration a comfort in the silence of deep cold. You feel the change in your body. Lips crack from dryness. Fingertips stiffen despite layers of gloves. Breathing recycled oxygen feels sharper, colder, as though each inhale carries ice. The skin itches under thermal liners, sweat freezing if ventilation falters. Hunger grows faster in the cold, metabolism demanding more fuel, meals measured carefully so stores last until spring. History already gave warnings. In 1976, Viking recorded winter frost on its instruments, a glaze of carbon dioxide that coated metal. In 2018, the global storm struck just before southern winter, cutting solar power and ending opportunity. For colonists, those dates are not trivia. They are lessons carved into memory. Storms, frost, and cold will combine, and only redundancy keeps death outside. Daily life shrinks in winter. Crew gather closer, sharing warmth in common rooms. Lights dim to conserve power, hydroponics slow growth, some trays shut down. The smell of fresh leaves fades, replaced by the sterile odour of packaged rations. Sleep cycles lengthen, bodies conserving energy like animals in hibernation. Outside excursions are rare, limited to urgent repairs. Every airlock cycle is weighed against the cost in heat and power. You imagine walking out into winter twilight. The sun hangs weak, shadows long, frost sparkling across dust like ground glass. The sound of boots is muffled, the world silent, colder than the inside of freezers on Earth. Breath fogs the visor, then vanishes in the thin air. You check instruments constantly, each gauge a countdown against cold. There is no tolerance for error. The psychology shifts. Winter presses not just on machines but on minds. The horizon feels farther, the silence heavier. Conversations trail into quiet. Some crew write journals, some sing softly, some sit staring at heaters. The hum of the reactor becomes not only energy but rhythm, proof that time continues. Spring always returns. Carbon dioxide sublimates, pressure rises, light strengthens. Panels clear, batteries recharge, crops grow greener. Yet colonists never forget the season that came before. Winter teaches humility. On Mars, survival is fragile, and winter is the sharpest reminder. Before anyone sets foot on Mars, the hardest trial begins not on its soil, but in the long, slow voyage through deep space. The journey takes 6 to 9 months, depending on the launch window, a half-year locked in a ship that drifts farther from Earth each day until home is only a pale star behind. Distance is measured not only in millions of kilometers, but in how much of your body and mind the ship consumes. The first days echo with noise. Engines thunder briefly, pushing the craft onto its transfer orbit, then fall silent. Pumps hum, fans spin, screens blink. You float in microgravity, body adjusting with nausea, inner ear confused, stomach rebelling. Muscles ache from doing nothing, bones begin to lose strength. Every motion feels clumsy, each sip of water drifting in spheres before lips catch it. The air smells of metal, plastic, recycled breath. There is no breeze, no freshness, only the quiet weight of machinery. Weeks pass and rhythm sets in. Exercise becomes law. 2 hours a day strapped to treadmills, lifting resistance machines that fight against vacuum pistons. Sweat beads float, salty globes that must be wiped before they short circuits. Food tastes bland after days of rehydrated packs. Every sound carries, a cough, a sigh, the click of a keyboard. Privacy shrinks to a curtain around a bunk, a pocket of silence in an ocean of recycled air. Outside, the view is absolute. Through a window, Earth shrinks until it becomes a pale dot. Mars is invisible, waiting ahead like a promise hidden in black. Stars blaze sharper than ever seen from ground, unfiltered by atmosphere. Silence is so deep it feels like a pressure against the skull. You realize space is not empty, it is heavy with distance. Radiation adds its invisible weight. Inside the hull, dosimeters tick slowly upward. Earth's magnetic field is long behind, and cosmic rays now strike freely. Some come as protons from the sun, others as heavy ions from beyond the galaxy. You feel nothing in the moment, yet the body absorbs their presence. Curiosity's sensors in 2012 estimated that a round trip to Mars could expose a crew to around 0.66 sieverts, close to the lifetime limit set by some agencies. Numbers turn abstract until you imagine them written in cells. Protective walls line parts of the ship, water tanks surround bunks, food stores double as shielding. In case of solar flares, a storm shelter sits at the centre, layers of hydrogen-rich plastic forming a cocoon. Crew drill for the day, a burst from the sun sweeps through space. Alarms would sound, everyone would huddle inside listening to instruments tick while charged particles lash the hull. In 1972, such a storm erupted between Apollo missions. If astronauts had been caught outside Earth's field then, the dose would have been lethal. That memory haunts every calculation. You stretch in the narrow gym, heart racing faster under the resistance straps. Muscles burn, lungs ache in thin, recycled oxygen. Exercise keeps bones from dissolving, keeps heart from shrinking. Yet the awareness remains that gravity is absent, replaced by machines pretending to be its twin. Days blur together. The journey is not danger in drama, but danger in patience. Slow erosion of body, mind, and spirit. Each breath tastes the same, clean, metallic, recycled. Each night sounds the same, hum of fans, occasional thump of water through pipes. Dreams drift between Earth and Mars, waking always in the same narrow berth. Deep space strips away variety, leaving routine as shield against despair. Survival here means discipline. Lapses are not forgiven. The ship becomes the world. Outside is silence filled with radiation. Inside is noise filled with repetition. Between them stands only thin alloy and human stubbornness. Half a year in such a state does not simply carry you to Mars, it transforms you, testing whether fragile bodies and restless minds can endure distance without breaking. Distance is not measured only in kilometers but in time, in the long pause between sending a word and hearing the reply. On Earth you speak and someone answers instantly. In space the delay grows, seconds at first, then minutes, until conversation becomes half a dialogue. By the time the ship nears Mars, each message takes more than 20 minutes to cross the void one way. Questions linger unanswered. Laughter fades before it can echo. Comfort arrives too late. You send a message home and wait. Screens glow softly. Voices return with static distorted by distance. A mother says goodnight to her child. The child has already gone to school by the time the signal arrives. Crewmates joke that they are ghosts in each other's lives, always out of sync. Loneliness here is not the absence of people around you, but the fracture of connection with the world you left behind. The ship fills the silence with rituals, shared meals, exercise hours, storytelling in narrow bunks. Crew learn each other's voices too well, each sigh or cough recognizable instantly. Conflicts brew faster under confinement, but they also resolve faster. Necessity demands it. Outside is nothing, so inside must hold together. The delay with Earth makes the crew not just travellers, but pioneers of self-reliance. Technology grows toward easing that burden. Engineers at SpaceX and NASA designed Starship as a vessel, not only of steel but of community. Its volume is vast compared to Apollo capsules, more like a house than a car. Ceilings tall enough to float without hitting walls, bunks spread apart, gyms, common rooms. Even with space, loneliness remains. but design matters. A ship that feels like a cage breaks minds. A ship that feels like a home stretches endurance. Starship depends on stainless steel shells, methane-fueled Raptors, and refueling in orbit. Without tanker flights to top its tanks, it cannot leave for Mars. Tests in the 2020s showed how difficult it is to master orbital refueling, yet without it the journey remains only a dream. Colonists watch every launch, knowing their path depends on those bright plumes rising from Boca Chica. You imagine standing in the wide bay of such a ship. The floor hums with circulation pumps. The air smells faintly of insulation and steel. Windows reveal nothing but black. A crewmate drifts past, nods, returns to a panel glowing green. Time stretches. The voice of Earth lags. Friends become memories, and the ship itself becomes both prison and promise. Designers argue over shielding, redundancy, recycling. Can the ship carry enough mass to block radiation? Can hydroponic racks grow greens to ease the monotony? Will artificial gravity by spinning modules ever be added?